section 7.6, function operations. Our objectives are to add, subtract, multiply, and divide functions, and define the composite of functions. Now, these first 5 are just problems we've done before, so you should pause the video and then unpause it and we'll talk about the answers. All right, so to look at the first part, for number 1, we have x squared minus 1 plus x plus 1. There's no numbers in front of the parentheses, so I don't have to distribute, and there's no powers to each of the binomials, so I don't have to FOIL. So for the first one, I'm just going to go ahead and combine like terms. My like terms would be, in this case, the 1 and the negative 1. So when I do that, I end up with my answer being x squared plus x. Then for number 2, I have to distribute this negative sign here in order to simplify this problem. So when I distribute, I end up with x squared minus 1 minus x minus 1. I have like terms. My like terms are the negative 1 and negative 1, which when we combine that together, we get negative 2. So x squared minus x minus 2 would be the simplified answer. If I look at number 3, for this problem, I have a binomial times a binomial, so I need to FOIL. So remember, when you FOIL, that means we have our first terms here. So x times x would give me my x cubed. So this should be an x cubed right here. That's my fault. So x times x would give me x cubed, and then x squared times 1, my outside terms would give me x squared. Negative 1 times x would give me negative x, and negative 1 times 1 would give me negative 1. So x cubed plus x squared minus x minus 1 would be my solution, and I cannot simplify that any further because there's no more like terms. And for the last one, this is a division symbol right here, so I'm dividing. Now, we learned how to divide using synthetic division. That's what we've been working with. So most of you probably did this, put negative 1 in the box, and then in standard form you have 1, 0, negative 1 because you're missing, you have 0x that you're missing. And then when you do your synthetic division, you're adding, you bring down the first term. 1 times negative 1 is negative 1. Negative 1 plus 0 would give me negative 1. Negative 1 times negative 1 is 1, and then 1 and negative 1 is 0. So then when you do that, you end up with x minus x, or sorry, x minus 1 would be your solution. Now, the new thing is, for these problems, you're not going to want to simplify your problem this way because you're going to then miss something that we're going to talk about in a little bit, which is restrictions. Now, for restrictions, restrictions are going to be restrictions that I have on variables that we will talk about. And so the way that, if you remember from earlier in the year, if I instead factor this problem, so I did x squared minus 1 divided by x plus 1, if I factor x squared, which is the difference of squares, I get x plus 1 times x minus 1 over x plus 1. Remember when we were doing rational functions in chapter 9, we said we can simplify these because they're being multiplied by the binomial, so those cancel out, to leave me with x minus 1. But remember, we also had restrictions. Remember, we said that we can't have 0 in my denominator. So right here, if I were to set this equal to 0 and solve, I get x plus 1 equals 0 and x is equal to negative 1. If I were to plug negative 1 in for x here, notice I would get negative 1 plus 1, which is 0. But remember, we can't divide by 0. So now when we have these division of functions, we have to watch out for our restrictions. I know that x cannot be equal to negative 1 because it makes my denominator 0. So you can, when you're doing these, use synthetic division to check your answer, because notice that we got the x minus the 1 here for our solution, but we also need to be careful of what we're dividing by cannot be equal to 0. So then for the next problem, we're given that g of x is equal to this function, and we want to evaluate g of negative 3. So remember, that's function notation when I have g of negative 3. That means that I want to figure out what is the y value when x is equal to negative 3. So I plug that negative 3 in here and here into my equation. Notice that when I plug it in, I put it in parentheses because when you square a negative, it becomes positive. So in this case, when we simplify this, we get 18 plus 9 plus 1. So g of negative 3, when we add that together gives me 28. So that's our function notation. So now we're applying all of what we just learned and all this notation, and we're applying it to operations on functions. So you're going to want to write these operations down. For the first one, for addition, if we have f plus g of x, it's equal to f of x plus g of x function. For the next one, if we have f minus g of x, it's f of x minus g of x. For the next one, f, and this right here, this means multiplication, so f times g of x is the same thing as f of x times g of x notation. Here we have division, f divided by g of x becomes f of x divided by g of x, and again here g of x cannot be equal to 0 because remember we cannot divide by 0, so that's really important. Now, for this, what does that mean? So let's go up here to this warm-up that we did. So for this warm-up, and instead of writing that these equations all out, let's say instead I said f of x, we're letting f of x equal x squared minus 1, and I'm going to let g of x be equal to x plus 1. So for like number 1 here, instead of just writing x squared minus 1 plus x plus 1 that they would have written in the problem, f of x plus g of x, which would have been, then you would have written this down and then simplified it. So this one over here would have been f of x minus g of x. This one would be f of x times g of x. And this one here is f of x divided by g of x. And remember, g of x can't be equal to 0. So that's what we are doing for our function operations. Now, something else we're going to talk about is domain. If you go back to the first chapter, remember we talked about domain, and we said the domain was all possible x values of the function, so the things that we're plugging into our equation. So the range then is all possible y values of the function, so our outputs, things that we're getting out when we plug in our x values. Now, your domain is mostly all real numbers, except for we have 2 restrictions. So the times when our domain is not all real numbers are these restrictions that we have right here. So this is a big deal. So I'm going to actually take this and move it down and make it a little bit bigger so that you guys can read it a little better. If I extend my page. So this right here is big. You want to make sure you write this down. Now, the domain restrictions means that the domain is not all real numbers when the following happens. Variables that make our denominator 0. And those, to find those, we set the denominator equal to 0 and solve. So we only have to worry about this when we are doing division of functions. So that's why we said if we had the f divided by g of x, which was the same thing as f of x divided by g of x, where we said g of x cannot be equal to 0. That's what we did for the above problem. And the second one is variables underneath even roots, because remember, we can't have a negative underneath the radical because it becomes imaginary. We are not going to talk about number 2, really. We're going to only deal with number 1. So this is what we need to look out for. If we don't have a variable in our denominator, then that means that our domain will be all real numbers. So if no restrictions. So if you don't have any of those restrictions above, then the domain is all real numbers. So that sign just stands for numbers. And the symbol that we use for all real numbers is you draw 2 lines and then make an R. So this is just the symbol. And again, it means all real numbers. That's the symbol you're going to see me writing down. So let's go back up here and do some of this. So for these examples, it says, let f of x equal, and there's function we're given right here, and g of x is equal to x plus 2. Perform each function operation, state the domain and range of each function. So we're not going to state the range, we're just going to go ahead and state the domain of the function. Now notice that for the first one we're doing f plus g of x. That means we're just adding these 2 functions together. So I have 3x squared plus 2x minus 8, and then I'm adding that to x plus 2. So when I add that together, I I'm doing like I did for the first problem, just combining like terms. I don't have any exponents and I don't have anything in front of my parentheses to distribute, so I'm just combining like terms. So I get 3x squared, 2x and x gives me 3x, and negative 8 and 2 is minus 6. So that would be my simplified version. If you look here, we look to see what the domain is. Do I have any variables in my denominator? No, because I'm not doing division of the functions, and I don't have any radicals in any of these equations, so I know that my domain here is going to be all real numbers. Remember, that means all real numbers. Now we're going to do subtraction of functions. So now instead of adding, we're subtracting, and again, notice that I always like to put everything in parentheses, because if you don't, then you might miss the fact that right here we have to distribute that negative to each of my terms. So this is 3x squared plus 2x minus 8 minus x minus 2. And then after you distribute, you combine like terms. So 3x squared, 2x minus x gives me 1x, so plus x. Negative 8 and negative 2 is minus 10. And again, I don't have any restrictions because there's no variables in the denominator, and I don't have any radicals to worry about. So my domain for this one is, again, all real numbers. So the next one, I'm multiplying my functions. So I'm doing 3x squared plus 2x minus 8 times x plus 2. And I like to use the box method when I'm multiplying, so I'm going to go ahead and box that out. And then when I combine like terms, I have 3x squared, or cubed, sorry, 3x cubed. And then I get plus 6x squared and 2x squared, so plus 8x squared. And then 4x minus 8x gives me minus 4x, and then minus 16. So that would be my answer when I FOIL this out. So remember, these were like terms here, and these were like terms here. And for my domain, I'm not dividing by anything, so there's no variables in my denominator. And I don't have any radicals in any of these equations because we're not doing that yet. So the domain is all real numbers. For D then, now we're dividing two functions, f of x divided by g of x. So in this case, I have 3x squared plus 2x minus 8, now divided by x plus 2. Now remember, I said when you're doing these, we want to factor them because that's going to help me with my restrictions. So when I go ahead and do that, I have to factor this top equation, which remember, I'm going to do this off to the side. We can use our slide and divide rule. So take this, multiply by the last term. And then I set up my two binomials. Factors of 24 that add up to 2 would be x plus 6, x minus 4. And then remember, we divide by the number we slid by. And then the next step would be to reduce the fractions. And this doesn't reduce, so we swing the number in front. So that would be my factored form. So I'm going to go ahead and write that up here. So we have x plus 2 times 3x minus 4 all over x plus 2. And I'm going to erase this so I have room to write. And remember that when we have from our rational functions, if these are the same and they're being multiplied, we can go ahead and cross those off because those would cancel. And we would be left with 3x minus 4 for my solution. However, since we're doing division with two functions, the domain is the next thing I want to look at. Well, I have variables in my denominator, so how do I find what the restriction is going to be for the domain? I take x plus 2, set it equal to 0, so x in this case is equal to negative 2. So if I do negative 2 plus 2, I get 0 in my denominator. So my domain then, we would say, is all real numbers, but x cannot be equal to negative 2. So that would be my solution. For the next one, notice we're doing f of x minus 2 times g of x. So remember, this is function notation, so we're taking the 2 and multiplying it by the entire g of x equation. So f of x, remember, was 3x squared plus 2x minus 8, and then minus 2 times my g of x function, which is x plus 2. So then I'm going to distribute. So for this next one, I get 3x squared plus 2x minus 8 minus 2x minus 4. Combine like terms, 3x squared. The 2x and 2x would cancel out, so I'm left with minus 12 because negative 8 and negative 4, so that would be my answer. Then I want to look at my domain. So my domain in this case, I don't have any variables in the denominator anywhere, and I don't have any radicals, so it's going to be all real numbers. For the next one, this one's a little bit different because notice I don't have x in my equation, I have 2 and 1. That means we're evaluating our function for f of 2, an x value of 2, and an x value of 1. And then I'm going to add those two answers together. So I'm going to do that separately. So when I plug 2 into my x equation, I get 3 times 2 squared plus 2 times 2 minus 8. And when I simplify this, I end up with 12 plus 4 minus 8, which is just equal to, in this case, 8. So that's f of 2. Now I need to do the second part, which is f of 1. So 3 times 1 squared plus 2 times 1 minus 8. When I do that, I end up with negative 3. So remember, the original problem was f of 2 plus f of 1. So when I do f of 2 plus f of 1, I'm really doing 8 and then minus, or I should say plus, negative 3, because that was plus there, and 8 plus negative 3 gives me 5. So that would be my solution. Now for this, the domain, I don't have any variables in my denominator, and if I were to graph this, y equals 5 would be a horizontal line. So the domain would be all real numbers. So again, make sure you have that written down. Now let's do the second part. So the second part we're doing is compositive functions. For compositive functions, this is a little bit differently because we have a different notation. So notice this is a circle right here. Do not confuse that with what we did over here. This is a closed circle, which means multiplication, whereas over here, this is an open circle, which means that we are doing a composite of functions, which we'll talk about. So this means that you're going to evaluate the inner function first, and then use your answer from step 1 to input into the outer function. So you're saying, Ms. Thorne, what is the inner and outer function? Well, right here, g of x is my inner function, and f would be my outer function. And these are just two different ways of writing it. So I can also do the opposite of that. What if I instead did g circle, or g of f of x, can also be written like this, g parenthesis f parenthesis x, g of f of x. So notice that for this one, f of x is my inner function, and g is my outer function. So again, f of x would be the inner, g would be the outer. So let's go ahead and do some examples with numbers first, and then we'll get to plugging one function into another function. So for the first one, it says let f of x equal x minus 2, g of x is x squared. We want to find g of f of negative 5. So that means that first I evaluate my inner function. So if I rewrite this, I can write g parenthesis f parenthesis negative 5. These are just two different ways of writing the same problem. So notice that my inner function is f of negative 5. That's the first thing that I want to evaluate. So that means everywhere I have an x here, I'm going to plug in negative 5. Notice I put it in parentheses. So if I combine that, I get negative 7. Now that means I'm taking this answer, which is f of negative 5, and I'm going to plug it into here into my equation. So I'm taking out f of negative 5, and I'm going to put in this case, negative 7. So that's my step 2, is now I'm doing g of negative 7. And when I do that, I get negative 7 squared, which would be, in this case, equal to 49. So that would be my solution. Now let's do the next one. For the next one, I'm evaluating g of f of 2, which we can write as g parenthesis f parenthesis 2. So again, my inner function is f, so the first thing I want to evaluate is f of 2. So 2 to the third power is 8. Then I take that answer, because the second step is now I'm going to evaluate the outer function, which is in this case g. So g of 8 would be equal to 8 squared plus 7. 8 squared is 64, plus 7 gives me 71. Now, even if I did it the other way around, let's say I wanted to find instead f of g of 2, so the other way around. So my inner function is g of 2, which would in this case be equal to 2 squared plus 7. So 4 plus 7 is 11. And then my outer function in this case would be f, so I'm plugging this into my equation for f. So that would be f of 11, which would then be equal to 11 cubed, which is equal to 1,331. So this would be my answer. Now, for the next part that we're going to do, instead of plugging numbers into the equation, we're going to plug in one function into the other function. So if I go up here back to number 1, now notice that I'm doing f of g of x, which we can rewrite as f parenthesis g parenthesis x. As so my inner function, notice, is g of x. And before, we were plugging in numbers like 2, and then we did g of 2, and then plug that answer into f. But now we're plugging in the entire function of g of x. So my inner function is g of x, which in this case is 3x. I'm then, for the second part, evaluating f of g of x. So in this case, instead of g of x, we said g of x was equal to 3x. And my f function, notice I have one x here. So in that case, I have something squared minus 1. Well, if it was f of 2, I would do 2 squared minus 1. You agree? So if I had f of 2, it would be 2 squared minus 1. Instead of plugging in a number here, we're plugging in an entire function. So I'm plugging in 3x squared minus 1. And then 3 squared would be 9. X squared is just x squared minus 1. So this would be my composite of functions. It means you're taking one entire function and plugging into the other function. So we took this whole thing and plugged it in for x right here. So now if we do it the other way, we're going to get something else. So now I'm doing g of f of x. So first function is my inner function, which is f of x, which is equal to x squared minus 1. So now we are going to plug that into my g function. So I like to do g parentheses. So g is 3x, so I'm plugging something in for x. Just like if it was g of 3, I would do 3 times 3, or if it was g of 4, I would do 3 times 4. Now instead we're plugging in this entire function. So when I do that, I need to distribute, so I get 3x squared minus 3. So this would be my answer for g of f of x. And notice that they're not the same, so we get different answers when we do the different composite functions. Now for the next part, for the next one, we have the same thing except for two different equations. So I can rewrite this as f circle g of x. It means the same thing. So my inner function is g of x. And my outer function is now f of x. So I'm doing my outer function, which is f parentheses. So everywhere I have an x, I'm going to put parentheses because I'm plugging in my function to that. So I'm plugging in x squared plus x minus 1, x squared plus x minus 1, combine like terms and simplify. So x squared plus x plus 2, because I'm going to combine the 1 and the 3, which gives me 2. Now for the next one, keep going, we could rewrite this as g circle f of x. So my inner function is f of x. And f of x now is equal to, remember, x plus 3. Now we're taking this and plugging it into my g function. So g parentheses would be equal to, notice that there's 1, 2 variables here that we have to plug something in for. Just like if I had g of, let's say, 3, I would do 3 squared plus 3 minus 1. But we're not plugging in 3, we're plugging in this entire f of x equation. So that's why I'm going to do parentheses squared plus parentheses minus 1. What goes into the parentheses? We're plugging in the entire function of f of x right here. So x plus 3, x plus 3. Here we have a binomial squared, so we have to FOIL that. So x plus 3 times x plus 3 plus x plus 3. I can just drop the parentheses, minus 1. When I FOIL this, I get x squared plus 6x plus 9. And then combine like terms. So when I combine like terms, I'm going to, whoopsies. I'm going to just go ahead and do x squared plus 7x. 9 plus 3 is 12, minus 1 gives me plus 11. And that would be my g of f of x. So let's do one more example because this is a little bit more complicated. So for the last example here, you're going to have to write this down. F of x is equal to 3x. G of x is equal to x squared plus 7. So for the first one, we're doing our inner function, which is g of x. And in this case, g of x is x squared plus 7. So then the second step is, remember, we're doing f of g of x. So we just said g of x is really equal to x squared plus 7. So that's what we're plugging in for x into my equation. So we have 3 times x squared plus 7. So this distribute would be 3x squared plus 21. And then for this one, our inner function would be f of x, which is 3x. And then our outer function is g of x. So we're doing g, and we're plugging something in for x. So what's that something that we're plugging in? F of x, which we said was equal to 3x. So we get 3x squared, which would be 9x squared plus 7. And then that's what we're going to be doing for these problems. And again, the only difference is instead of plugging numbers into my equation, I plugged in a whole equation. So instead, I wanted to do f of g of 1. In this case, I would first do g of 1, which would be equal to 1 squared plus 7, which equals 8. And then my second part would be doing f of g of 1. So g of 1 was 8, so f of 8 would then be equal to 3 times 8, which is 24. So instead of doing that, we unplugged in an entire function into my equation. So for the last part of this are these graphs for domain and range. We are not going to do these graphs in the video. We will go ahead and talk about these graphs in class. So make sure you bring the rest of the stuff with you, and then, like I said, we'll do a lot more practice of this in class.